Okay, so we're now on to arithmetic sequences in series 5-2. So the goal for this unit is to be able to find the nth term and arithmetic means of an arithmetic sequence and to find the sum of the terms of a sequence or series. So an arithmetic sequence is a sequence in which the difference between successive terms is constant. So the difference between the terms is the same every time. That difference is called the constant, or the common difference. So the constant in the arithmetic sequence, which we call D, is the common difference. So for these problems, determine the common difference. We're trying to find D and find the next four terms. So if we look at the difference here, it's going to be, should be the same between each set of numbers. So from 17 to 12, we're going down 5. 12 to 7, we're down 5. So D is -5. Right? And then it wants us to find the next four terms. If we continue going down 5, 7 minus 5 is 2. If we continue that, 2 minus 5 is -3. And we continue that, -3 minus 5 is -8. And then continue one more time, -8 minus 5 is -13. So the next three terms in the sequence are 2, -3, -8, and -13. So you're going to do the same idea with these. What is the common difference? If it's going down, it's going to be negative. If the numbers are going up, it's going to be positive. So the nth term of arithmetic sequence can be found using a formula. An equals the a1, which is the first term, plus n minus 1 times d. Okay, so that's the formula we're going to be using to find these answers. So example 2, find both the explicit formula and a recursive formula for the nth term. So we're going to start with the recursive. Right. The recursive formula, again, builds one term to the next. So we always start by defining our first term. So the first term is 12. And then we're going to write an equals an minus 1, because that's the term before, so the 12. And then because it's in arithmetic, what is the common difference? What is changing? So this is going up by 9, so then we're going to add 9. So what this formula is saying is we take the term we have and add 9, we get the next term. If we take the term we have and add 9, that's what this formula is stating, and we're saying which term did we start with. So that's the recursive formula. The explicit formula, we're going to follow the formula given here. So an equals the first term, which is 12, plus n, which we're going to leave as n because we don't know which term we're looking for, minus 1 times d, which was positive 9. And then we're going to simplify that by distribution. So we distribute the 9 this way, 9n minus 9. And if we continue simplifying, we have 9n plus 3. And so the explicit formula would be, if we take 9 times the term number and add 3 to it, we'll get the value. Okay, so that's the explicit. This is the recursive. So you're going to use the same idea with this pattern to do your own two formulas. So then we have find the specified term of the sequence. So we're going to use that formula from the page before. An equals a1 plus n minus 1 times d. This d can be written up here in the front as well, which I'm going to do that because I find that it's easier. So it's the d times n minus 1, because we usually distribute from the front. So I just moved the d to the front. This is multiplication, so the order doesn't matter. So we're going to use this formula here to do these next problems. So we want to find the specific term. We want to find the 68th term. The term number is n, so n is 68. Of this sequence, which starts, so a1 is 25. And then we can also find d, the common difference. So each time in this sequence, it goes down by 8. So -8 is d. So we have identified our variables. Once we have our variables, we can plug them into the formula. So we're trying to find A68. N is 68. What is the 68th term? If we start at 25, we go down by 8 each time, and we're finding the 68th term. So we plug in for n, anywhere there's an n, 68, anywhere there's an a1 is 25, and d. And then we're going to simplify. So 68 equals 25. If I distribute 8 times 68 minus 1, so the first thing I'm going to do is plus negative 8 times 67. So in parentheses first, and then we have 68, 25 plus this multiplies to negative 536. And if I add those together, negative 511 is the answer. Okay, so we're plugging into the formula the information that's given to us. So each problem looks a little different. When you get to the worksheet, you'll see ones like all these, so make sure you find the one that's most similar. So we're trying to find now A1. The first term is A1. That's what we don't know. We do know A25 is 139, so we know AN equals 139. We know N is 25, and we know D is 3/4. So if we go to the beginning, AN is 139. A1 we don't know, that's what we're looking for. D is 3/4. N is 25. And we're minusing 1. So I'm plugging in all the known. You'll always know everything but one variable, and then you solve. So 139 equals A1. Sorry, plus 3/4 times 24. If we do 3/4 times 24, we can get 18 plus A1 equals 139. So if we minus the 18, A1 equals 121. So this sequence starts at 121. It goes down up by 3/4. At the 25th number, it will be 139. That's what that is telling us. So then the last one, we want to find D. So D is the unknown. We know A1. We know AN equals 56.5, which means N is 38. So we see this notation, that is AN, and N is 38. So we start with AN is 56.5. We know A1 is 75. We don't know D, so we're going to leave D. We know N is 38. So then we simplify 56.5 equals 75 plus 37 times D. If we minus the 75 to the other side, we get negative 18.5 equals 37D. And if you divide, D is negative 0.5. The arithmetic means is the terms between the two known non-consecutive, which means they're not in order, terms of a sequence. So when you want to find the arithmetic means, you're looking for unknown values. So write an arithmetic sequence that has a specified number of arithmetic means. We need 4 means between 4.3 is the lowest. We need 4 values between here. And 12.8 is the highest. So that is what's asking. What are the 4 numbers that go in here? To determine the 4 numbers, you do the difference of these two. So you take the 12.8 and you minus the 4.3, which gives you 8.5. Okay, so 8.5 is the difference between these. We need to divide it equally to find these spots. So we have 1, 2, 3, 4, 5 spots we have to divide by. So we're going to divide 8.5 by 5, and that's going to get us 1.7. So for each of these, we're going to go up 1.7. So the first value would be 6. Then we go up 1.7. The next value is 7.7. Up 1.7. The next value is 9.4. Up 1.7. The next value is 11.1. Up 1.7, the next value is 12.8. When you get to the end, it should match the right number if you do this correctly. So how many different increments of increase do you have? That's what you divide by. If you want to think about it, if you're looking for 4, you add 1 to that, you're going to divide by 5. So on this one, we're looking for 6. So if we add 1, we're going to divide by 7 once we get our difference. So you're going to work this one out. Make sure you put 6 means you need to put 6 blanks between the two numbers and then divide by 7 instead of by 5 and do the same process. So now let's talk about some ideas of the sequences. So we talked about arithmetic sequence. We're going to look at that a little bit more, and then we're going to go into what happens if it's not arithmetic. So the first differences you find by subtracting the terms. So we find the difference here, it's a difference of 5. The difference here is a difference of 5, and the difference here is a difference of 5. So this is the first differences are all the same. When the first differences are all the same, the sequence is linear. So, well, first the sequence is arithmetic. That's the word we've been looking at. So if the first difference is if these numbers are all the same, it's an arithmetic sequence and it's modeled by a linear function. And a short way to write that linear function, an equals d times n plus a0. A0 would be the initial term. So that's our linear function. It's kind of like slope-intercept form. The second difference is, let's look at these differences. So our first difference here is 8. This one is 10. This one is 12, and this one's 14. So those are our first differences. Now let's do our second. 8 to 10 is 2, 10 to 12 is 2, 12 to 14 is 2. So in this case, the second differences are the same. So when the second differences are the same, it can be modeled by a quadratic. Okay, and the generic formula is an equals an to the second plus bn plus c. Okay, and that's how we write our quadratic formula. So then it says, find a quadratic model for the sequence. So to do this, we're going to use some of our matrix work that we've done in the previous section. So that's why it's important that we learn that information. So to do this, we're going to make a model following this example. So we're going to start with, this is the first term, this is a second, this is a third, and so forth. So we're going to look at the first term only. Okay, the answer for the first term is 12. Okay, so we're following this model, and we have a, and the term number is 1, so 1 squared plus b times 1 plus c. If I simplify, I have 12, 1 squared is 1, b times 1, and then c. That's my simplified version. So I just wrote a equation with 3 variables. If we write an equation with 3 variables and we want to be able to solve, the number of variables tells us the number of equations. So we're going to need to write 3 equations. That's the first one. Let's go with the second term. So the second term is 20. If we plug in for term number, n is 2, we have a times 2 squared plus b times 2 plus c. If we simplify that, we get 4a plus 2b plus c. So there's our second equation. Now we need a third one, so let's go to the third term. You could use any term you wanted, but we're just going to go in order. So 30 is a times 3 squared plus b times 3 plus c. Again, we're plugging into the formula. And if we simplify that, we get 9a plus 3b plus c. And there is our set of 3 equations that we can now use our skills we've learned from matrices to solve. I'm going to use diagonal rule with Kramer's rule to solve this. You can use reduced row echelon if you would rather. I figured Kramer's rule is the most recent. So we are looking for A, B, and C. And Kramer's rule, we learned it as X, Y, and Z, but we're going to just go A, B, C. So I'm going to write these, or kind of like make sure we see these are the equations we're working with very clearly. So if we identify, we have the answer is, so if I write in the other order, we have 1a plus 1b plus 1c equals 12. We have 4a plus 2b plus 1c equals 20. And we have 9a plus 3b plus 1c equals 30. And if you remember the formula, and if you don't, we're going to look at it right now. To find the first variable, on the top, we replace the a, because we're looking for a, with the answers. So we put the 12, 20, 30, where the a coefficients would be. And then we keep our b, 1, 2, 4, or sorry, 1, 2, 3. We keep our B the same, and we keep our C the same. Okay, so the A, to find A, we replace the A with the answers. The denominator is just the coefficients of this side. So we have 1, 4, 9, 1, 2, 3, 1, 1, 1. All right, and then to solve this, we use diagonals. So to do diagonals, if you remember, you take the first row and recopy it. You take the second row and recopy it. So we have 12, 20, 30, 1, 2, 3. And if we go on our diagonals, going this way and going this way, let's figure out our values. So going down, 12 times 2 times 1 is 24. I'm going to write the work up here. We're going to add it to 1 times 1 times 30. And then add that to 1 times 20 times 30. And then we subtract going the other way. 30 times 2 times 1 is 60. 3 times 1 times 12 is 36. And 1 times 20 times 1 is 20. And if we add these all up, we get 114 minus 116, or negative 2. So my numerator is negative 2. All right, and then we're going to do the next row below. So we're going to copy, again, these numbers over here, these numbers over here. So this is 1, 4, 9, 1, 2, 3. And then if we do our diagonals, going down, 1 times 2 times 1 is 2. 1 times 1 times 9 is 9. And 1 times 4 times 3 is 12. And then going the other way, 9 times 2 times 1 is 18. 3 times 1 times 1 is 3. And 1 times 4 times 1 is 4. And if we simplify that, we get 23 minus 25, or negative 2. So my denominator is negative 2. So if I do negative 2 divided by negative 2, A equals 1. We have our first value. Okay, now we're going to find B. To do B, we got to do the denominator, but if you remember, the numerator stays the same. Or sorry, we have to do the numerator. The denominator stays the same. So the negative 2 is still on the bottom. If we're doing B, we're going to keep the A values, the coefficients of A, as they were. We're going to replace the B coefficients with the answer. And then keep the C as they are. And we're going to copy our first row, 2 columns. Let me just get my highlighter so we can see that. So we copied this over here and this one over here. And now we're going to do our diagonals. So coming down this way and then going across this way. And I'm going to put the work underneath because there's more room. So 1 times 20 times 1 is 20. 12 times 1 times 9 is 108. And 1 times 4 times 30 is 120. And then going the other way, 9 times 20 times 1 is 180. 30 times 1 is 30. And 1 times 4 times 12 is 48. And if we simplify that, we get 248 minus 258, which is negative 10. So we have negative 10 over negative 2, so B is 5. All right. Once we have 2 answers, we can go back to our original equation. A plus B plus C is 12. So A is 1, B is 5, C is C, equals 12. C comes out to be 6. So the answer is 1, 5, 6. And we want to write that into the quadratic model. So AN equals, A is 1n squared plus B is 5n plus C is 6. And this is a quadratic model that would give us a sequence. Okay, so if you put in n is 1, you'd get 12. N is 2, you get 20. N is 3, you get 30. N is 4, you get 42, and so forth. So that is the way you're going to solve that using systems of equations. There is an example like this. The next one you're going to try on your own, and there is one on the worksheet as well. Okay. So now fill in the differences in the table showing the values. So if it's a first difference, it is a linear model. If it's a second difference, we just said it's a quadratic model. If there's a third difference, it would be a cubic model. Okay, so remember linear is just x, quadratic has x squared, cubic would be x to the third. Fourth difference would be a quartic, and that's x to the fourth, and then quintic is fifth. Okay, so just so you know when you're doing those differences, that's what information it gives you. To find the sum of an arithmetic series, there are two formulas. Depending on the information you're given, you might use this formula if you have n, a1, and an. And this formula, you do not have an, you have d instead. So depending on the information given to you, it depends on which formula you use. So let's look at example 6. I wrote I do part, you do part, because I'm going to start the problem for you and then let you finish solving it. So on this problem, we know the first term, a1, is -5. Okay, we know the an, or the term ending term, is 317. And we know the difference between each value is 7. What we need to find is n. In order to use either of the formulas, they both require n, and we don't have n. So we need n. In order to find n, we're going to use the formula an equals a1 plus d times n minus 1. So we're going to use that original formula to find n. So let's plug in 317 equals a1 is -5, d is 7, we don't know n. 317 equals -5 plus 7n minus 7. If we move our terms to the other side, we're going to get 329 equals 7n. N is 47. Okay, once we have n, we'll add that to the list of things we know. We can go to our sum formulas and say Sn, or S if n is 47, the sum of the 47 terms, is 47 divided by 2. I'm looking at the first formula. Okay, so 47 divided by 2 times a1 is -5 plus an is 317. And if we solve that, we get 47 over 2 times 312, which is 7,332. So if I take the terms -5 all the way 317, going up by 7 each time, all those added together give you 7,332. The next one asks for the 28th partial sum. So we're looking at S28. What do we know? We can find D is -13. It's going down by 13 each time. The first number is 27. And we're looking for the 28th term, so we know n. So we're going to use the formula, the same formula again. Sn equals n over 2 a1 plus an. That's the formula we're looking at. So S28 equals 28 over 2, and for this one we can't use that formula. We have to use the other one because we don't know an. So we're going to use Sn equals n over 2 times 2a1 plus n minus 1 times d. So that's the other formula. So we're going to use that one. So then we have 2 times a1, which is 27, plus n is 28 minus 1 times d is -13. You use order of operations, so 28 divided by 2 is 14. 2 times 27 is 54. 28 minus 1 is 27 times 13 is, or -13 is -351. And if we simplify that, we get -4,158. So that is if we did 28 numbers and continue this sequence, 28 numbers, and added them all together. And the last one is in our sigma notation. So now let's see what we're going to use for this one. And I had said I do part, you do part, but I just did it all for you. So you won't have to do it. Just make sure you copy everything down. So we have the 6th to the 28th term. Okay, so we have terms number 6 to 28. If we simplify that and say this is my first term, because really we like to have the first term, if we minus 5 from 6, we'd be at term 1. So then we minus 5 from 28, we have a total of 23 terms. Okay, so that makes it easier because that tells me n is 23. I'm doing 23 numbers. The first number, A1, we're going to plug in 6 into this formula. 5 times, because it tells you 6, 5 times 6 minus 17 is 13. So A1 is going to be 13. Okay, and then we need to find the 23rd term, but we're going to plug in the 28 because that's what it actually is. So 5 times 28 minus 17 is 123. So now we're going to use our formula Sn equals 23 terms divided by 2, and then the sum of the two terms. And then if we simplify that, we get 1564. So now we have the word problems. How do we apply this? A video game tournament in which gamers complete multiple games and accumulate overall scores pay the top 20 finishers. First place is 5,000. Second place is 4,800. Third place is 4,600, and so forth. And they're doing 20 people. And we want to know the total money awarded. So we need to find the sum of the top 20 people. So what do we know? We know A1 is 5,000. We know the difference is each person gets $200 less. And we want to find the 20 total numbers. So if we use our formula, S20 is N, which is 20 over 2, times 2 times the starting number, which was 5,000, plus the number of terms, which is 20 minus 1, times the difference. So we're using the formula, the larger of the two formulas. If we simplify that, we get 10,000 plus 19 times negative 200. And if we continue simplifying, we get 10 times 6,200, which is $62,000 they would give out. So I'm going to tell you the next one. She gets 50 points at the first level. So A1 is 50. It says she gets 50 more each level. So she's difference is 50 at each level. And we want to know the total amount after 9 levels, so N is 9. So those are the defined values. You're going to plug that into the formula and solve it. For number 9, we're going to actually skip number 9 and 10. Okay, so just make sure you do number 8, cross out 9 and 10 unless you want to try them.